For our first one here, we're asked to graph a parallel line to this line that they give us. Well, whenever we think of parallel, think of its slope. The slopes have to match. So two parallel lines have that same slant or that same slope. So we're always looking at the slope triangle for these in order to even start the problem. So it looks like we have a point at -1, 1, and we have a point at 0, -1. So I'm just going to go ahead and draw that section a little bit bigger so that we can kind of work with that slope triangle more. So this one right here, from -1 going to the left, that's actually, you know, when I like to do these, I like to follow like kind of the math direction. When in math, usually we go left to right. So when I think about my slope, and that's what we're focused on, it's rise over run. So we're going to focus on our rise first. That's usually what I like to do. So from left to right, that's right up here, I go down 1, 2. I went down 2. That's in the negative direction. And then I run 1 to the right in the positive direction. So this was my rise, this is my run. So m is equal to -2 over 1. Now sometimes students get confused with the negatives and when they go. So another option is you have to remember that this is going downhill from left to right. That makes it negative. Then you don't have to worry about any of the signs. You just have to remember as a last kind of filter, is it going uphill or downhill? And I always like to do that too, because in the past I've forgotten my negative signs or I get them wrong. And it's really easy just to check visually, is it going uphill or downhill? I got my negative sign correct, it is going downhill. So this is my slope of this line. I'll call it m1 is equal to -2 over 1. That's m1 for this. And then I need to graph a parallel line. Do you remember what I said parallel lines have for slope? They have the same slope. So for my second line, my second line has to have exactly that same slope, -2 over 1 for that one. So I'll go ahead and it doesn't matter where I put it so long as I rise -2 and I run +1. So I'll go ahead and have a y-intercept of 2. So I'll start here. I'll rise -2, down 2, 1, 2, run 1 in the positive direction, 1. Remember, rise over run. If you need to write out that form to help you, that's perfectly fine. Then I'll go ahead and just connect those. And in geometry, they say 2 points define a line. So we can connect those. If you wanted more, you can go down 2 and over 1, and it'll keep giving you more points. They all should land on the line. Unless you've made a mistake, all you need are 2 points. Okay. But if you are prone to mistakes, having 3 points, that'll help you because you probably are not going to make the same mistake over and over again. There'll be a little bit of a different variation. All right, next one. So I've graphed a parallel line. Check. The key was having that same slope. Next, draw a perpendicular line. Give slopes of all lines. Okay, so I went ahead and I did 2 of these because they gave me a flat line, and that's kind of a special case, so we just have to be careful with that. Do you remember what I've said in the past about perpendicular slopes or perpendicular lines? There's 2 things that you need for the perpendicular slope. You flip the fraction and you change the sign. Flip the fraction means reciprocal. Change the sign means opposite. So we're taking the opposite reciprocal. For me, I just think about it as I flip the fraction and I change the sign. So if it's positive, changes to negative. If it's negative, changes to positive. And then the fraction flips. Remember, slope is always a fraction. Rise over run. You always look at change in y and change in x. All right. So this first one, like I said, is the tricky one. Well, I wanted to also say, what's this equation? A lot of students, they forget or they don't know how to do these equations. Notice this is only touching the y-axis. It only touches the y-axis. It never touches the x-axis. This line has no x in it. It only has a y. And my trick is whatever axis it crosses, that's the letter it has, and the number. So this crosses y, so it's y equals at where? -4, and that's the equation of the line. Okay, well, there's a couple different things to think about here with regards to slope. For this one, I think I have more of an understanding approach to dealing with it. But notice, if I wanted to write it as y equals mx plus b, this would be the -4 part and 0 for the x, because these two match. They're the same. So I can definitely see 0 for slope here. But like I said, for an understanding level, I like to look at it as a flat line. What's the slope of a flat line? There is no slope. It's a 0 slope. It's not harder or easier walking on the ground. It's flat. Now, just be careful. Think about the other case that you might have, a straight up and down line. Well, is that easy to walk? No, it's really hard to walk. In fact, it's like the slope is 0. The slope gets more. It gets bigger slope. Really big slope. The slope is so big, they call it undefined. So it's an undefined slope for when it's straight up and down. So the slope of this line, M1 is equal to 0. You remember what I said? We can always make it as a fraction. 0 over, and I'll just say 1 on the bottom. It doesn't matter what number I put. But it is okay to have 0 on the top. This answer is still 0. Now, if I draw a perpendicular line, I'll go ahead and do this one. I'll make it cross at 3. Do you remember my trick? What's the equation of this line then? What's the equation of this line first? Well, it crosses the x-axis. It never touches the y-axis, so it's only x equals something. Where does it cross the x-axis at? At 3. So, that's just the equation, x equals 3. But we're looking for the slope here. Do you remember my trick for the slope of a perpendicular? We flip the fraction and change the sign. So the slope of this one, M2, the slope of this line, if I flip that fraction 1 over 0, is it okay to have 0 on the bottom of a fraction? It's one of our rules. No, it is not okay. That is the undefined. They don't let us have that. It's so steep, it's undefined. So the slope here of this one is undefined. It's the straight up and down. And left and right, that's just 0 slope. Okay. Now, I did want to do like a real one so we can practice doing the opposite reciprocal or flipping the fraction and changing the sign on this. All right. So, draw a perpendicular. I did that and give slopes for all. Okay, I did that. Just checking to make sure. All right, so this be like my third problem, and then I got my fourth problem I'll do next. Okay, first we need the slope of this one. So it goes from -5 up to. So I went up to this one, and then I run 1, and then I went to the right 1. So that's right 1. All right. So this triangle that I just built, that slope triangle, I'm doing it a little bit bigger so you can see it, had a 1 for my run in the positive direction, to the right's positive, and a up to, which is positive also, +2. Remember, this is the negative direction for x, and the negative direction for y is down there. So there's my slope triangle. The M1 for this one, M1, rise over run to help you out. The form, so I rose 2 is 2 over 1. So there's my slope of this one. The first one is equal to just 2. When you're writing an answer, usually we don't need that fraction form. The fraction form is really important if we start using it or describing it. In this case, we're just stating what it is. But now I want the perpendicular. I have to have the perpendicular slope. It's like an upside down T for that perpendicular. All right, so for the perpendicular slope, do you remember the two things I said you have to remember for perpendicular slope? The math words would be even better, but the simplest way of saying it is we flip the fraction and change the sign. Reciprocal, opposite. So I flip this fraction right here, since it's already in fraction form. What's 2 over 1 flipped? 1 over 2. And we change the sign. This was positive, now it becomes negative. Now, it's really important that we pick a place for that negative sign. When we talk about slope and rise and run, negative in front doesn't help us. So we want it either on the top or on the bottom. It doesn't matter where. So this is also equal to negative 1 over 2 or equal to 1 over negative 2. These two are the ones that we can use. Either one, it doesn't really matter. We're not reflecting over any lines, so we're not restricted to using one or the other. So either one of these we can use. All right. So now it doesn't matter where we pick our y-intercept. I'll go ahead and just pick it at 1. I'll pick it at 1 here. So I'll start there. So it doesn't matter where I draw it. I'm drawing a perpendicular. They didn't restrict me on this one. So I like doing this one first. I like taking care of my negative right out of the way so I don't forget. Down 1. So that's a rise or a down 1 and a run or positive to the right 2. So I go down 1 and to the right 1, 2. So that's where the other point would land. And I can keep doing this if I wanted. But that should be enough if I connect those. Notice it has kind of that perfect cross look, and that's what we have to have. So there's our slope of the perpendicular, negative 1/2. I'm using that one because I'm not actually rising and running. If I'm applying it, then I have to have that negative. And there's the drawing too. Draw a perpendicular, give slopes of all the lines. So there's the slope of the first one and the bottom one. All right. Last problem. Equations that are parallel to this one. Well, do you remember what I said to think of when you hear parallel? Slopes are the same. Well, this one's a little bit hidden. It's kind of muddled up with how they wrote it. It looks like it's written in like a standard form or I think it's called standard. It's where the form I'm thinking of is where the number is by itself, the constant is by itself, and then all the variables are on the other side. But we need to put it in a form that we can see it a little easier, the slope. Do you know what form has slope in it for lines? It has the slope word in the name. It's called slope-intercept form. Why do they call it slope-intercept form? Because it has slope and the y-intercept clearly visible when we convert it. So I'm going to go ahead and convert it into slope-intercept form so I can see the slope. The key for slope-intercept form is you get y by itself. So I'm going to move everything that's not attached to y over first, and then if it is attached to y, I'll go ahead and remove that so y is by itself. I move everything that's not attached to y to the other side. Plus 5x, plus 5x. Now slope-intercept form, it's good to remember, it's y equals mx plus b. So y is by itself, and the x comes in front of the number. So when I add this together, I'm going to make sure the 5x is in front. I now have 8y equals 5x minus 16. You cannot combine these. These are x's, these are numbers. You can only combine like terms, so they do have to stay separate. The last step here is we're getting y by itself. The opposite of multiply by 8 is divide by 8. What you do to one side, you do to the other side. The whole side gets divided by 8. So my trick is I like to do each term by term. That way you don't have to continually break it down. Every term gets divided by 8 for this one. You can always divide everything by 8 and then break it up, but this is a lot easier to do and less likely to trip if you break it apart a little easier this way. So that's 8's cancel, y equals. We want to put that 5 over 8 in front so we can see it as a slope. So x times that. So that's 5 over 8 times x. A number times a fraction multiplies straight to the top. So you can also move it out because those are equivalent forms. And 8 into 16, the negative sign stays the same, and that's just 2. Do you see the slope? Y equals mx plus b. Your y-intercept is by itself. The slope is always next to x. The slope gets affected the most quickly by that x. The y-intercept, the starting value, that just kind of stays the same and always stays there. So it's -2 in this case all by itself. So in this case, equations that are parallel to this would be y equals 5 over 8x plus any constant, where that constant is an element of the real numbers. It could be any number right there. The key is any equation that has 5 over 8 in front of x is a parallel line to that one. Well, if you had something that was jumbled up and you're trying to match it, then you have to kind of take the long way and solve it for y so you can see what the slope is. This is pretty much the easiest, most direct way to find the slope, so we have to be able to see it in order to match it.